I'm Dr. Godandaraman. In this section, we are going to discuss with the Lagrange's linear equation. A linear partial differential equation of the first order, which is the form of capital P small p, capital Q small q, R. Here, P, Q, R, the function of x, y, z is called the Lagrange's linear equation. To solve this equation, it is enough to solve the auxiliary equation. The auxiliary equation is nothing but auxiliary equation dx divided by capital P, dy divided by capital Q, dz by capital R. This is our auxiliary equation. The general solution of the auxiliary equation, general solution of the equation pi of uv equal to 0, pi of uv equal to 0, where pi is nothing but pi is an arbitrary function, and u is depending on x, y, z variable equal to some constant, and v x, y, z equal to b, or independent solution of simultaneous differential equation. To solve the auxiliary equation, we have two methods. One is method of grouping, and second one is method of multiplier. Method of grouping and method of multiplier. So method of multiplier, method of grouping, consider the auxiliary equation. Consider the auxiliary equation dx by p, dy by q, dz by r. So this is our auxiliary equation. Take any two term. First two term, or second and third term, or 1 and third term. So consider any two term. Now we have considered the first two term. So consider first two term. First and second term is nothing but dx by p, dy by q. If in this p and q have any z values, z variable other than x and y, try to eliminate it. Okay, if in this pq any z variable, then eliminate. Now direct integration, when I am taking direct integration, it gives u of x comma y equal to some constant. Similarly, take another two term. Maybe now already we have considered 1 and 2. Now should consider 2, 3 or 1 and 3. Now I am consider here second term and third term. Second term and third term. If in this two term, again if in this two term q and r contains any x variable, then try to eliminate. Because here whatever the variable we have considered this from the auxiliary equation, if xy means only the variable in terms of x and y, constant no issue, but z variable anything is there, try to eliminate. Anything is difficult, whenever I am taking any two, it's difficult to eliminate, then the other method is method of multiplier. From this, once I am integrating for this equation, integrating dy by q dz by r, then we have the solution v of x comma y. Sorry, here the variable we consider y z, therefore y z equal to one constant. Now the general solution is nothing but Lagrange's equation of the general solution, pi of uv equal to 0. So this is our method of grouping. And second method of multiplier. Method of multiplier. In the method of multiplier, choose any three multipliers. Choose any three multipliers. Choose any three multipliers L, M, N, which may be constant, constants or functions of x, y and z, such that now we consider the auxiliary equation dx by p, dy by q, dz by r. From here L dx plus m dy plus n dz divided by L into p, m into q, n into r. Now we have considered some constant k. From this case, now I am going to take L dx, m dy, n dz equal to k into L into p plus m into q, n into r. If Lp plus mq, n r becomes 0, then L dx plus m dy plus n dz equal to 0. And then direct integration. Now direct integration, we get the value of u of x comma y comma z. After the integration u of x comma y comma z, we consider some constant. Similarly, choose another set of multiplier. Similarly, choose another set of multiplier. Maybe consider L dash, M dash, N dash. Therefore, dx by p, dy by q, dz by r, L dash dx, M dash dy, N dash dz divided by L dash p, M dash q and N dash r. As usual, the previous above procedure, when the expression, if we consider k or any other term maybe we consider. This term L dash dx, M dash dy, N dash dz equal to k into L dash p, M dash q, N dash r. If L dash p plus M dash q plus N dash r 0, and then L dash dx plus M dash dy plus N dash dz equal to 0. Now integrate directly, integration. So now direct integration gives the value of v of x comma y comma z to another constant. I'm consider b. Finally, the solution of the Lagrange's equation is nothing but pi of u v equal to 0. This is our solution. So these are the basic information and working procedure for Lagrange's linear equation. And then now we are going to discuss with one of the problem, Lagrange's method of grouping. Look at this problem. Solve xp plus yq plus z. And this problem, first to process the auxiliary equation. What is the process? Look at this linear, Lagrange's linear equation. Capital P small p, capital Q small q equal to r. For here, capital P is nothing but x, capital Q y, and then capital R z. Now the auxiliary equation dx by p, dy by q, dz by r. In this form, I am going to substitute p value, q value, then z value. I mentioned earlier, so choose any two term, first term or second term or third term, or first term or third term. Now first I am choosing first two term. Now consider first and second term. Therefore dx by x, dy by y. Look at this one, this two term only x and y. Suppose any z variable, then try to eliminate it. Now integration dx by x, dy by y. So after this integration, dx by x integration is log x, dy by y log y. Then the constant maybe to take c or c1 or a whatever, but simplification purpose I'm taking log a. It's easy for simplification. Only the reason I'm taking log of a plus log of b is nothing but log of ab. Then this log x. When I remove the log on both sides, x equal to ay and a equal to x by y. Now what is the u? U is nothing but a, therefore u equal to x by y. Now this is one of the solution from this equation. And then next we consider second and third term or first and third term. Now consider second and third term. Now I am taking consider second and third term. Second term dy by y, dz by z. Now integration of this, integration dy by y, dz by z, and log y equal to log z plus the another constant log b. When I multiply this, log of a plus log of b is nothing but log of ab, and this log y. Remove the log on both sides, therefore y equal to bz and b equal to y by z, then v equal to b, therefore v equal to y by z. Now the general solution is nothing but pi of uv0, then pi of u value is nothing but x by y, and v value y by z equal to 0. So this is our final solution. Thank you.